are having this type of session in Cyber Week. We are this year celebrating the 13th year of Cyber Week, and this is for the first time that we are having not a session. We have, we have 50 conferences. We have hundreds of sessions, but the sessions are more, let's discuss a topic that we all familiar with, or at least we assume that we all familiar. A course is something a bit different. We say, okay, this is a piece of content that we want to share with the audience, and we hope that at the end of the session, the audience get a value of knowing better a specific content or specific methodology or specific practice or something like this. And this is the goal of this session that we are running for the first time. I haven't said I'm Yaniv Arel, and this is nice to be here. I'm the Chief Strategy Officer of the Cyber Center here in the Tel Aviv University, with years of experience from the government, from the industry, running the Cyber Solutions Group of Dell Technologies, and also Signia and other companies. And it's my pleasure to meet you here this afternoon. We are having the Cyber Center of Tel Aviv University on top of the research that we have in our center, in the entire interdisciplinary domain of cybersecurity, from the very technical up to a very humanistic domains like legal, economy, and other parts of cybersecurity. So while we are looking at the cybersecurity in so broad way, here we are taking today part of the technical domain of cybersecurity, and on top of the research that we have in our center, so we have also educational programs, and this type of lesson that we are going to have this afternoon is a lesson that is part of our program with our partners from DART, that they are not only experts in cybersecurity, but they are also very strong practitioners. So the lecture that we are going to have here this afternoon, the mini course, is not only about the theoretical part of this domain, but this is a very practical experience, a very practical content that is based on the experience of the colleagues. The last point that I want to make is the fact that we have chosen this topic for a reason. We are all talking about the cyber challenges and the cyber solutions, but we are not spending enough time and attention about the cyber vulnerabilities. We are not, sometimes we skip the issue of cyber vulnerabilities and we jump to the solutions. Forget the deep reason, but let's talk about the solution. And we believe that it's very important to spend time to understand deeply what are the vulnerabilities, what are the real reasons of how the attackers or how our systems create the gaps or create the penetration points in which the attackers can attack our systems later. So in order to emphasize this area, and in order to start with this as the foundational part of cybersecurity, we've decided to dedicate the first mini course to this part, to the introduction of the software vulnerability research. So with that, I would like to wish you a great Cyber Week, a great session here to learn. In a minute, we'll find also how to improve the air condition a bit here in the room. This is a technology challenge that I hope that we'll overcome, and I hope that you will enjoy this as well as enjoying the Cyber Week and your visit in Israel for our guests from other countries. So thank you very much, and with that, I will invite Dean, the CEO of DART. Please.
So first, thank you, Yaniv, for this introduction. I want to, before Barak will start the lesson, I want to say a few words. mainly about in this area of technology advancement, we found ourselves increasingly relying on software, even for range of usages, including medical management, including even on the national state. So we have a critical question. How secure are these software systems? Software vulnerability research is the critical discipline to answer this question. As the software designed by humans most likely will have a bug or a flaw. This bug is not simply inconvenience sometimes. Sometimes it can hide a true way for a malicious attacker to step inside. And I just want to say a few words and to emphasize that I think learning vulnerability, software vulnerability research is the key asset to start and understand, to think like the attacker. Basically to understand what they will look for within the software, how they will look for it, and eventually how to prevent it. We believe in doing the proactive approach instead of just waiting for the threat to start. And with this, I want to give you basically a good lessons with Barak and enjoy.
So many introductions. Thank you very much, everyone. So hi, good afternoon. My name is Barak. Today we'll talk about לא עובד. So we're going to talk about vulnerability research. This talk, I'll give an overview of this topic. So if anybody is not familiar with vulnerability research, this is a really good starting point. I want to demystify a little bit some of the fog that surrounds it in a not too technical way, so everybody can understand, regardless of your background. We'll talk about why vulnerabilities exist, like what causes them to happen, and also a lot about the process of the vulnerability researcher, okay? Let's get into it. Oh. All right. נראה לי בטריות. Okay, so I'm a trainer at DART, consultancy and training. We do capacity building for government-level organizations, mostly focusing on nation-level threats. I have a lot of experience in hacking PC software, embedded cars, automotives, and I want to hear a little bit about who I'm talking to. I want to gauge your technical level a little bit. So raise your hand if you're a student here in TAU, in TAU. Oh, wow. 2 students. Okay. Everybody are guests, so welcome. Raise your hand if you've ever programmed in C. Great. Perfect. Assembly. Any kind of assembly. All right. Similar amount of hands. How about high-level languages? Anybody programmed in Python, C#, Java? All right. Anybody done any QA? Okay. We're in good company. Okay. So anybody knows what a SQL injection is? Okay. All right. So seems like you do have quite a lot of technical background. Click all over. A lot of technical background, so we can go through this part quite quickly. What is a bug? And I want to hear what you have to say. So what is a bug, aside from those you see on the street in Tel Aviv every day? Like, does anyone have just one sentence? What is a bug? Like software. Something that's a feature. Yeah.
Anything in the product that doesn't work as expected.
Thank you. So the key word is expected. So what is intended and what's effectively happens. So in this case, I don't know if you can see, but this is car parking system that shows a green light if it's free and a red light if it's not free. And obviously, since it's in a third world country in Ecuador, so there's a green light even though there's a car there. So that's not expected. It's a bug. Okay. Information security. It's a huge topic. But what is it in brass tacks, in a nutshell? There's no one answer. You can tell me what you think.
The way we try to save our information.
Great. So the effort of protecting information. Has anyone heard of the CIA triangle?
Yeah.
Huh? So I'd like to talk about the CIA triangle in a very concise way to talk about information security. I see people from the CIA, they're smiling. So confidentiality, basically protecting secrets, protecting privacy, so nobody has access to your information. Integrity, the information that you get, making sure that it is correct, nobody has tampered with it. And availability, so protecting against disruption of services. So we spoke about bugs a little bit, but what are security bugs? As the name implies. Anybody have a short explanation? What is a security bug?
A function that causes a security entry point for an attack.
A function. What do you say? A function that causes?
A function that a malfunction
Malfunction. Okay.
that causes an entry point to compromise the security asset.
Perfect. Well said. So malfunction or like any flaw in the code in software that acts as an entry point for somebody, for some threat actor, to harm the security of the system. And we are speaking about security bugs today in code, in software. So there's also the idea of the general idea of a weakness or a vulnerability, which is anything that harms the security, the information security, let's say, of an organization. So this could be the guard is asleep at the entrance and everybody can walk in and just take a computer, right? But today, when I say vulnerability, I mean code vulnerability or software bug. Okay. Another example is keeping the router password as the default password. And the idea of trust is the basis of cybersecurity. So let's say we have an employee in our organization, and they're not too security savvy. Okay, if they get a PDF from an unknown email address, they will just open it. So even if the software was perfect and the CISO did everything that's humanly possible to protect the organization, it could take one person to break the chain of security. The scary situation is if all the employees are performing perfectly and all humans don't open emails from unknown addresses. However, they don't even need to open the email because the software they're using is vulnerable. That's when trust is broken. So as an example, has anybody heard of Curveball, this vulnerability? Okay, so would you access your bank account from a public Wi-Fi? Who would do that? I'm curious. Who doesn't have a problem logging into their bank account?
Only those who don't know
Well, so it's not optimal, but usually there shouldn't be a problem accessing a bank account from any Wi-Fi because public key cryptography and TLS give us end-to-end protection. Okay, we can verify the identity of the website we're surfing to, browsing to, because my computer has the cryptographic signature of my bank, and my browser uses a TLS library to establish a secure connection, making sure that it is really bank.com. So in a perfect world, this should be enough for me to access my bank account. However, what happens if the library, the code that performs this TLS connection, what if it is vulnerable? It has a security bug, and then I trust Chrome, the browser that trusts it, but the whole chain collapses. Okay, so that's a problem with trust, and that's an actual vulnerability in elliptic curve cryptography in Microsoft Crypto API, which affected Chrome and Internet Explorer, or Edge, it was already called. And that's the problem. So yeah, if I access my bank from public Wi-Fi and there exists this vulnerability and there's somebody in the cafe that exploits this vulnerability and attacks me, then yes, it's a problem. But these things are pretty rare.
In
All right.
this case, you can trust even if you do it in your home. Because if it's a bug in the TLS library, you can trust it even at home.
All right, it's a great question. What's your name?
So on.
Someone said that if your computer has a vulnerability, okay, the code inside your Windows or your operating system cannot establish secure connections. So even if you browse from your home, you can't really trust the bank website. And well,
Because you use the same TLS.
so it's true, but it would take an attacker that can intercept connection between your home and the bank, which means they probably attack the ISP or something like that, or the bank itself. So that's a little more far-fetched than somebody in the cafe. So security is always a matter of defense in layers, okay? Risk management, so yes, even if I don't browse from a public Wi-Fi, it could still get attacked, but it's more rare.
What is the cause of TLS is vulnerable in public Wi-Fi? What is the reason?
In this situation, in Curveball, so Curveball, there was a vulnerability and a bug, a software error, inside the crypto API. I'm not going to go into that because it takes a long time to explain the elliptic curve mechanism. But you need to look at it as boxes, okay? This box gives you the interface of a secure connection that validates whoever you're connecting to is actually bank.com. The vulnerability, we go back, vulnerability means that code is supposed to do something intended, but in effect, it's possible to make it do something else. So an attacker could make it think that it's connecting to the real bank.com while it is actually connecting to the attacker. Okay, so breaking the TLS, yeah, man in the middle. So yes, TLS should protect against man in the middle, and we trust it too. But if there is an implementation that doesn't do it properly,
What is the hint we are getting for the connection bits? What is the hint?
the hint?
Yeah, hint for the hackers. Like this is a public domain, and the information how they are getting the connection should be based. Like they are doing
You're asking how to implement a man in the middle, like
how they are able to what type of hint is getting so that they can breach it. Without hint, how they can do the database.
the database?
Without hint.
Hint.
Suppose today I read the brochure that today is agenda of today. So I got what are the things prior to me. So I categorized like that. So I came to this. So I get the hint about all the agenda. So like that, hackers how to get the hint from the public domain so that they can data, they can reach the data.
He's asking how the attacker will know whether he can exploit this COBOL vulnerability.
Ah, okay.
The cap. That's what
Okay, so it really depends on the vulnerability, but in this case, what it could do is just try and see if the connection is established. Then yeah, the victim used a vulnerable library. If it doesn't work, then they didn't, and just the connection would fail. So a lot of times with exploiting vulnerabilities in the field, it's try and miss, okay? The שיטת מצליח, you know, the מצליח method. It either you try it and it works, or it doesn't. All right. So now I want to give an overview about vulnerabilities. So the general concepts regarding it. So the term attack surface is a sum of all the ways a system could be attacked. So for example, in the city of Troy, the objective is to get in, the attacker's objective. They could get in over the wall, under the wall, through the wall, or through the gate. So each one of these is a possible attack vector. Some of them would not work, because if they go over the wall, then the watchman would see them, etc., etc. So the attack vector of going through the gate inside a AI-generated horse, that would be one attack vector, which, as the story goes, did work. So that's an important term to know. Some examples of attack surfaces. So if you have a website and we give it some input, okay, so if it's Google, we give it a search query. More technically, the search query is passed as part of the URL as a get parameter, if you're familiar with the HTTP protocol. If we're using Bluetooth, then Bluetooth is a lot of communication, and all of this communication is part of an attack surface on the Bluetooth device, on either of them, because there's exchange of information. A USB drive connecting to a computer, there is a communication protocol between these two computers. There's a little computer inside, et cetera, et cetera. Or documents. Okay, so there is a program, a lot of code that is used to parse PDF files. So the PDF is the input to that parser. If there is a vulnerability in the parser, then we can say that the entire format of the PDF file is the attack surface on the PDF parser. Okay. Any questions so far about this concept? Feel free to stop me if you want to ask a question. Great. So some considerations when we're talking about attack vectors. For example, is proximity. So if the vulnerability lies inside the Bluetooth communication, then that means to attack it, to use this attack vector, I have to be physically proximate or have a physical device under my control that is in proximity to my victim. If we're attacking something over the internet or an IT network, then do we have access? Is there any firewall? If we are trying to attack something in North Korea, I don't know, can we even access these servers? So even if there is a vulnerability on some server there, that doesn't mean that the attack vector exists. Okay, the attack vector is the entire chain. If we take attacking a mobile phone, for example, over a mobile network like LTE, so let's say I have a vulnerability in an SMS parsing code, but can I even send an SMS to that phone, to that mobile number, or would they be blocked? And another interesting thing is privilege. So let's say we have a website, and it has a vulnerability in some web page, but that web page, you have to have credentials, you have to be logged in order to access it and to apply the attack on the attack vector, then we would say that this is an authenticated vulnerability, requires authentication. Okay, so now a little exercise. Let's say we have a platform that has authentication. It's a recurring theme in many platforms. And let's say this is how the code for the authentication looks like. So I would tell you to find what's the problem here, what's the vulnerability in this code. But there's something missing that you need in order to do that. Okay? It's this. Because this code uses a function. And without knowing how this function works, you would not know how the code works fully. Okay? You have to know all the building blocks that the code relies on to understand exactly how it works and in order to be able to find a vulnerability. Okay. So can anyone explain what this code tries to accomplish? Yeah.
It tries to authenticate a password. It gets a password as input, and then it compares it to an original password that is correct.
Yeah.
And if it is correct, then it authenticates you.
Perfect. Thank you. Great. So that's what is intended. So the key here is exact password. Okay, the input should be completely identical to the real password. A spoiler: it doesn't do exactly that. Why? What's the mistake here? Let's give a few seconds to think about it. Some more things, if anybody is not too familiar with programming. So this is a calling to a function, passing first parameter as the real password, second parameter is the user attempt, third parameter is the length of the user attempt, and then taking the return value, and if the return value is equal, then login successful. Yes.
Is that saying that if the user enters 1 byte of password, it's only going to compare the first byte?
Is that what it says? Yeah, you're correct. It says that if you call the len of the user input, and the user gave in only just 1 character, then this value would be 1. And the number of bytes to compare would be 1. So there would only be comparison of 1 byte between the real password and the user's password. So if this is the real password, what could I enter in my attempt in order to log in successfully, even if I don't know the real password? Yeah. So how would I know that it is caps lock M? Yeah, you just try it. There's not many options, so you just brute force it. If there's some protection, then it might be a little more complicated. But obviously, you shouldn't be able to enter by knowing just the first character. Okay? Who understood the vulnerability here? Raise your hands. Great. Okay. So let's talk about it again. No, sorry. Okay. So show me hands who understands what this means. Len, calling of len. All right, so I think that's the problem. Len, user input, let's say that it is the string m. Len is a function. You give it a string, some data, some text, and the return value is the length of this string. So what is the length of this string? 1. So when we call memCompare when the user input is m, the value that's going into num is going to be 1. Right? Okay. User input 1 character, num would be 1. That means we call memCompare and we tell it, hey, can you please compare these 2 strings, but only compare the first byte. That means the user or the attacker can control how many bytes to compare or how many characters to compare between the real password and his or her attempt. So this is obviously a very silly vulnerability, and you probably won't find it. Sorry?
But if you do brute force,
Yeah.
won't they block you?
It depends on the platform.
After 2 or 3 trials,
Yeah, Instagram might block you, but some other platform might give you 2 tries a day. So, after a month or 2, you're on an average case, you would gain access. Okay. So in this situation, the attack vector is the password input. And there's no required privilege because it's a vulnerability in the authentication. And in this case, this is a publicly accessible internet website. So, and of course, this is a pretty simple vulnerability, which you probably won't find in Instagram or any big company. But it's a good exercise to understand what vulnerability means. Okay. So this is, in general, cybersecurity, information security significance for individuals. I don't think we need to go through this too much. Obviously, privacy, theft of funds, identity, even losing access. So if I could bypass the authentication and I can get access to somebody's account, I could change the password, and then they no longer have access to that account. So in the CIA triangle, that would affect the availability. Organizations, a lot of similar things, although you could add legal repercussions and reputation in here. Country level, state level resources and establishments which are important for the functioning of the country. If there is a vulnerability in services, digital services of the country, then these things could be harmed. But all of this is true for cybersecurity in general, okay? Not just the software vulnerabilities. Now this is an interesting case. Who is familiar with Celebrite? You work at Celebrite?
No, but I'm familiar with the event itself.
Ah, great. So who's familiar with Celebrite? Okay, Celebrite is a company that they provide a service of entering locked phones. For example, in the case of, for example, there's a terrorist attack and the police seizes the iPhone of the suspect, and they want to get in to get intelligence and understand more things. Then this product uses a vulnerability to unlock the phone, because obviously Apple designed their phones that only the true user can unlock them. If the police wants to unlock them, that's not intended. You need a vulnerability in the iPhone code in order to do that. Celebrite does just that. One time, a few years ago, an app called Signal, which is instant messaging, and they're really big on privacy, they declared war on them. And what they did, they got their hands on one of the Celebrite kits, and they actually found a vulnerability, or multiple, I don't remember, in the kit itself. So that means that, hypothetically, if there is a phone that knows, okay, let's say somebody knows about the vulnerability in this system. They can craft a phone in such a way that when the Celebrite kit is connected to it, it will actually attack the kit itself. It could change, for example, the information that is retrieved from the device. It could fake information, and that raises an interesting question, because now will the judiciary system actually trust, or can the police trust the information retrieved from Celebrite devices? Okay, so this is all games of vulnerabilities, right? It's a very interesting case. Remember when it happened?
Around 2017, if I'm not wrong.
How much? 1.5? Yeah, a few years back. It was very interesting. Okay. So, who does this? We can separate it to two categories: the black hat and the white hat. So the black hat, they do this in order to take advantage of the vulnerabilities. Whether it's offensive cyber warfare, a country that wants to attack another country digitally, or criminally, for example, a criminal organization using vulnerabilities to hack into somebody's phone and find out where they are, so they can go and beat them up, or stealing money. These are some examples. The white hat side is more for defense. So, for example, the opposite example of offensive cyber warfare is defensive cyber warfare. So somebody that works for a country could look for vulnerabilities just so the attackers could not use them against the country's services. Bug bounties is companies giving out prizes and incentives for people to look for vulnerabilities in their software. And when they do, they get money when they find it. And the last two is interesting. So vulnerability research is hard. Okay, when somebody finds a vulnerability, it becomes their entire personality, and they just talk about it all the time, because it's a lot of prestige in finding vulnerabilities, especially as you find them in more and more prestigious companies or products. Okay, if somebody finds a vulnerability in iPhone, then it's worth a lot of money, but also it's worth a lot of fame. Okay. So we can divide vulnerabilities to two categories. First one would be logical vulnerability. This is usually something in the design. So when a product software is designed, then in this example, somebody says, let's add a feature that users can upload photos. So that's great. But they're also not thinking in this case about many problems that could arise from adding this feature. The better situation is if, while they say, okay, let's let users add photos, they also say, let's make sure that there's no abuse that can be done to this mechanism. Because, for example, if they allow uploading photos, but they make no verification whatsoever on the actual files being uploaded, then what stops an attacker from uploading malware or malicious script? So this would be a logical vulnerability. Okay. Another example. Who knows 2FA, two-factor authentication? Yeah. All right. So two-factor authentication when you sign up for some account, and when you log in, you also get a message, on, for example, on your phone with a code, right? And then you need to put that code in. So it's two factors. There's also the second device getting some information to verify your identity. Perfect. So what happens if there's some kind of platform that offers two-factor authentication, but I sign with a premium rate number? What can I do by doing that? What would that grant me?
What's a premium rate number?
So premium rate number, like, you know, American Idol. So when you call, you can vote, but it costs you money to make like a few cents or $1, I don't know, to make the call. So premium rate numbers are numbers that when you call them, it charges the caller. So the caller or the sender of the message. So who would be the sender of the message in this situation?
The company, so you charge the company money in according to the MFA they send you.
Exactly. So I can log in multiple times, and every time I log in, I get a little bit of money, right? And then I become rich. So this is a logical vulnerability. Why? Because it's just something they didn't think about. They allowed the feature, but they didn't think about a way to abuse this feature. Questions about this? Okay, so the other side is the technical vulnerabilities. Technical vulnerabilities is when an attempt is made to do something securely. However, maybe they change the the espresso machine in the office to a beer tap, so the programmer was a bit tipsy, and when trying to write the secure feature, they just did it incorrectly. Basically, it's a mistake that can be pinpointed to a location in the code. There was a good intention, but it was done incorrectly. So in this example, another two-factor authentication platform, the idea, they want to forbid international numbers, okay? Because they cost more to send SMS messages to them. So when they think about it in the sprint planning, they say, okay, let's reject numbers that begin with a plus sign. However, let's say that the system does not account for spaces. So if me as an attacker, I enter my number with spaces and then plus, let's say that it is accepted. Now let's say that another place in the code ignores the spaces. Okay, so when the verification area of the code does not account for spaces, doesn't care, but the area that actually sends the messages just removes the spaces. This is theoretical, just an example of a vulnerability that would be technical and not logical, because they try to implement some security mechanism to forbid international numbers so people can't charge the company money. But there was an error inside the code that made this possible. Okay, questions about this example? Theoretical example. Okay. CWE, common weakness enumeration, vulnerabilities. So software follows many different themes. There's lots of things that are recurring. For example, authentication is something that you can see in many different types of code. Many different platforms have authentication, and sometimes it's authentication done in many different ways, but each way could be seen in many different products, many different software. And since the code follows lots of patterns, the vulnerabilities or the types of mistakes, they also follow patterns. So here, for example, we have, this is an example. that in order to authenticate to, so bank.com, it knows if the client is authenticated, whether or not they have an authenticated equals 1 in the get parameter in the URL. This is obviously a very ludicrous example, but this would be categorized as CWE 603, okay? Use of client-side authentication. Because who should be in charge of the authentication? The server. If you let the client do the authentication, then this is an error this is a mistake that could repeat itself in many different companies, many different products. So there is a classification of that. And it's a very long list. If you're very bored, you can go through that. The cool thing is most vulnerabilities fit into one or even more of those. OK. So as I said, the software follows similar patterns or recurring patterns. And there's different domains. So I know a website could have lots of websites, lots of web platforms could have authentication code. But also there's the domain of the type of language. So if code is written in a low-level language, it's probably not a website, okay? But if it's in a high-level language, then usually it's code that does very different types of things. Does anyone, who doesn't know the difference between a interpreted and compiled language and machine code? Like, okay, who is aware of this, the difference here? Okay, yeah. Huh? Where? Complied. Interesting. Thank you. So now I want to talk a little bit about two examples of vulnerabilities in high-level code and a vulnerability in low-level code. So in high-level, for example, website, the intended use for login, as we said earlier, only authenticate if the user knows the password. A theoretical vulnerability would allow the attacker to bypass the authentication. If the intended functionality of the website is to serve web pages from specific set, think a box of files, then a vulnerability would be to leak files that are not supposed to be served to clients. So this is like high-level, very abstract actions that a user, a client, can do with the service, with the product.
What you describe is an exploitation problem, not an authentication problem.
The second one.
The user can be authenticated but not authorized to reach the
Yeah,
information.
different things. So this would be a wrong access control, let's say. Yeah. But what I'm saying is that if you think of a product as like as an interface or as a product that allows specific actions, then those are the actions usually that you could find flaws in. Staying inside the domain of the product. So as we said, a website that allows uploading files, and it saves the file name, but it doesn't check the extension. So if I'm user 17 and I uploaded a file called malicious PHP, and the website just lets me upload it, and then I try to access that file, what could happen, possibly?
Maybe we could run the code of the website and it could.
Yeah, exactly. You could make the website, the web server, execute the file that you had just uploaded. Okay, this is because the website allows uploading files and allows serving files, and also it can execute PHP files as code. So if I upload a malicious PHP file, malicious script, malicious code, I could make, in this theoretical example, I could make the server execute my malicious code and do whatever I want. So there's a classification for that. Okay. Now this is where it gets more interesting and more difficult as well. So low-level programming, it's characterized by direct manipulation of memory. Okay, if in Python I can just do I can make a variable with 100, like a list with 100 elements. I don't know how that works behind the curtain, how the memory is managed. But when I write C code or C++, let's say C, then I need to know precisely in each address of memory what exists there. And if there is some kind of error, or say a bug in the handling of this memory, that could lead to something called a memory corruption. I'll give you an example of a memory corruption. So what is intended, expected in a username change feature? I have the username here, Caspi, and I change the username to Barak, and the type remains the same, and everything else remains the same, but this string, this text, changed. It would be a bug if this could happen. Okay? If I enter a very long name and it changes the username, but also changes the user type to something that was completely unexpected. It's not normal user, not admin, nothing like that. It's just, hey, this is a bug. So how could we leverage this to being a security bug or security vulnerability? I have a question.
No, I want.
All right, answer.
If you can change it to, if you know the exact amount of base to put, and then you can put user type, let's say root user, and then you can have whatever privileges you want.
Great. So if as an attacker I can change the user type, which is not change the user type when I'm changing the username, this is a security vulnerability because I could change it to admin or root or God, super user. Anybody, okay, who knows what this type of vulnerability is called? Show me hand.
Privilege escalation.
Okay, interesting. Yeah.
Buffer overflow, yeah.
Okay, so it's a buffer overflow that gives me the ability of privilege escalation. We'll talk about that soon. Buffer overflow. Yeah. Or more technically, out of bounds write. So the bounds of the username is up to here.
The size of the array.
Exactly. So this is the bounds of the username. If when changing the username, I can write outside of the bounds of the username, it's an out of bounds write, and it's very dangerous. Who knows Heartbleed? Not many people know Heartbleed. Okay, so it's a vulnerability that has a logo and a jingle, so it was a very important vulnerability in OpenSSL. This XKCD explains the vulnerability. Can you see back there? Can you see what it says? Okay. So there's a client and a server. And let's say the client tells the server, wants to know that the server is still there. And they ask, are you still there? If you are, reply potato. And the client also says, the word I gave you is 6 letters long. So the server says, user Meg wants 6 letters, potato. So the server says to the user, potato. Okay. That's how it should be. Another example. The server, are you still there? Reply bird, 4 letters. And the server replies, bird, 4 letters. Now, if the user, okay, so it's important to note that the user, in this case, gives the word that the server should reply, but the user also gives the number of how long this word is. Okay? What would happen if the user says bird and 40 letters, not 4? What would happen? Possibly. Any ideas, guesses? Yeah.
You will get the bird and another a lot of nonsense that might have been stored.
Exactly. So bird is something in memory. If I tell the server, give me 40 bytes, 40 characters, starting from here, it would give me first these 4, and then it would keep going. Keep going, keep going, keep going. Does anyone have any idea what class of vulnerability this would be? Like how this would be categorized? Not exactly. Depends on where this memory is implemented, but do you remember this one?
And they didn't check it.
Yeah, so that would be an out-of-bounds read. So in this example, are you there? Reply hat, 500 letters, and then the server says, hat, Lucas requests the misconnection page. If the administrator wants to set the server's password key to blah, blah, blah. So basically, in this vulnerability, it is possible to trick the server into sending a big amount of memory, more than the intended memory for this feature of checking if it's still there. So this vulnerability was a really, really big thing. Okay, so it just basically means any server running this software is vulnerable to information disclosure, it's called. And if the password is in the memory, which effectively it was in many implementations of server code, then an attacker could simply exploit this vulnerability, get the password to the server, and then do whatever they want. Okay.
Hopefully it was only on Debian.
I don't remember exactly. So a few more examples. Anybody except for you know what this is?
Oh, the car mileage.
Yeah, there's a technical term for it. Yeah. So this is a very good representation of how integers work in memory, integers or numbers, how they work behind the scenes. There is a fixed size of memory for each number, and if you exceed the size of that memory, what happens? It wraps around back to 0. So this code, what it does is assigns a user ID upon signing up to the platform, let's say. What's the problem here?
If not, I can bypass the old user and take over.
Take over? Yeah.
Other users. So if I have, I don't know, 62,000 ומשהו יוזרים באינטיג'ר.
Okay.
So if I go past this number, maybe he will start user 0, he will.
Yeah, exactly.
Also to the sim.
So depending on the size of this integer type, that would dictate how many possible user IDs there are. And once the system gets into the maximum number, the next one would go back to 0. So I could sign up one day and get ID 0, which might be the ID of the administrator or even some other user. And then maybe I could log in as another user. Okay, this is, of course, not an expected situation when the code was written, but it's an integer overflow. Anybody ever done this? Okay, so the PS1, the Sony PlayStation, they had a protection on the software, on the code. So you could not download download the game and burn it on a CD and make it work, because it would check the DRM it would check the signature, the cryptographic signature, and it would say, oh no, this doesn't fit the disk, so I reject this physical disk. So what you would do is you would buy a legit PS1 game. You would put it in. The PS1 would check the signature. It passed because it's a legit disk that you bought, original from Sony. And right after it checks the signature, you take it out and put in the pirated copy of any game you want. It can be even a different game. This kind of vulnerability is called time of check to time of use because first it checks the integrity of the data, and then it says, okay, this data is valid, and then you change the data to be something else, and it doesn't notice the difference that you actually swapped the data. Okay, so this is a class of vulnerability. It happens many times, and it's a lot of fun. Okay, so what?
I missed PS1.
Great game, great games. So Crash Bandicoot. Each vulnerability grants some kind of ability. So in the case of the PS1 that we just saw, the ability was bypassing verification. So if it verifies that the disks are legit and I paid money for them, I can bypass that. Heartbleed that we saw before, the ability is disclosing information. It's interesting that sometimes a vulnerability, the same kind of vulnerability, could give different abilities for the attacker, for the exploiter. So in this situation, as you said earlier, yes, we get a privilege escalation because I change my user type from normal to administrator. But what else could I do with this kind of vulnerability in this situation?
You can check the length of buffer, and if there was any access to the buffer, what's after the buffer?
Yeah, so let's say the buffer begins here.
Yeah.
You can keep going wherever you want.
But you can put padding between buffers, between the different parameters, and just check if there was any access to the padding.
Think more practically. What you see here.
You have to stay with that one? Okay.
Yeah, in this situation, I mean, in this case.
The data of the buffer and write the data for the next part of the memory.
Okay, what's the next part of memory? Thank you. The code is in the memory right after the data, okay? And if we have a buffer overflow that doesn't check how long the username given is, then theoretically we could write over this, and keep going and write over the code. What does it mean if I, as an attacker, change the code of a program?
You can execute the malicious code.
Exactly, code execution. Changing the code effectively means I'm telling the program do what I want, depending on what's the code I write. Okay, because remember, code, and we're talking about a low-level language, assembly, compile the code, it exists in memory.
You can,
if I change it,
maybe you can leave a few bytes of memory that you know exactly that they should be changed. In every part of every.
Can I say
Yeah,
something
for example.
to that? But
Yeah.
at the same time, if someone can find out what those 4 bytes are, or whatever pattern you want, and then you can overpass it.
But if you can compare it to another version of the memory.
yeah. So you're talking about mitigations, protections. We don't have time for that today. Yes, I want to just say in a nutshell that vulnerabilities are so important, and yes, people think about how to protect and how to make sure that even if there is a programming error, that it couldn't be exploited into an actual working vulnerability. How that's done, it's out of scope for today. Yeah.
I'm sorry, but I didn't understand how do you
Okay, so this memory, let's say on the server, and the server allows me to change the username. It doesn't check how long the username I give. So if I write too long of a username, I can overwrite this.
Why, it will go override the next
Yeah, because memory
parameter?
is sequential. And as I said, in low-level programming languages, the programmer is in charge of manipulating memory and managing memory.
So
That's
if
how it works.
The amount of
Yeah,
allowable
exactly.
parameters, it will go to the next parameter and change it.
Exactly. Yeah. So in this case, you could overwrite this, and then you would overwrite this, and then you would overwrite the post count, and then maybe there's more data, and after the data, code.
More complicated, but can be done.
Yes. Okay. Any questions about why a buffer overflow in this situation could lead to code execution, malicious code executions? Any questions? Does anybody not understand? Sorry? Does anybody not understand why this is a problem? Okay, good. Okay, so let's talk a little bit about, we spoke about what vulnerabilities are, we understood what they are, why they affect security. Now let's talk how a researcher actually goes about finding them. So this is very similar to QA, okay? We're looking for mistakes in the code. To do that, we need to understand how the code works. We need to find the mistakes and see if they're exploitable, if they can be exploited for some security, to harm security of the product. So, does anyone know what this is? Great, a good company. So, the attack surface of an automotive system or a car. Think about a modern car today. I didn't want to put anything for litigation issues. So, a modern car. What kind of attack surface do you have on it as an attacker?
Infotainment system.
Infotainment, okay, yeah. Infotainment is the screen you have inside. Why is infotainment an attack, part of the attack surface on the car?
It's many.
Sorry?
It's not one, it's many.
Yeah, there's many, but we're talking about the infotainment now, this little screen inside the car. Why is it part of the attack surface? Okay, it's connected to the car.
And you have the car computer, and if you want, you can send you have many car computers for each module of the car. So if you have access to the infotainment to the other computers, you can.
Okay, but why did the guy say infotainment and not say the TPMS, the brake computer?
Because
It takes input from
The
users.
easiest way to
Great. That's the important part. Okay, great. So there's connectivity. It has Bluetooth connection, it has internet connection, GPS. All these things are an entry point for an attacker to attack the infotainment system. And since it's part of the vehicle, then attacking the infotainment system allows you to maybe keep on attacking different parts of the car, different computers, through the internal network. What other attack surface do we have aside from infotainment? Any ideas? Oh, great. So the key system, right? You click the key button, and it sends some radio transmission. There is some receptor inside.
Also starting the engine car today, you have
Yeah, the
not only lock,
keyless. Yeah. Great. So this is the Batmobile's infotainment system. Let's say it has 5G connectivity and Bluetooth. I want to zoom in on the Bluetooth one. So Bluetooth, it's not magic. There's a protocol stack. And that's what connects between the infotainment and the phone. when Batman connects his phone to the car, actually these two devices communicate using lots of different protocols. Who's familiar with the layer model, the OSI? Great. So you can think similarly, there's a Bluetooth. And the Bluetooth implementation, both on the infotainment and on the phone, they know how to communicate in different layers. So I could zoom in on the communication protocol of applications. These are applications that are on the phone. They communicate over Bluetooth with the infotainment system. And if I zoom in, for example, on the phone app, that also has a few components, calls, messages, caller ID. All of this is part of the attack surface. And even a message could contain different things like text, images, and this. All right. So, not very interesting. Reverse engineering is a methodology for discovering vulnerabilities. To do that, you need to obtain a copy of the software. So if the code, what you want to find a vulnerability is publicly available, such as an app on the App Store, then you can just download it. Maybe you have, if you want to attack the Batmobile, you have to get your hands on one and then extract its code. So compiled code, what you have on an end product, would be in machine code, or can be disassembled into assembly. This is very difficult to understand. However, these two is the same function, only one of them is in C and the other is in assembly. That means that in order to find vulnerabilities in compiled software, the researcher has to know how to read assembly. Another option is to use a program that automatically decompiles assembly back to C, but those don't always work very well. Okay. So let's say we got the code. Maybe we extracted it from the car. Maybe we downloaded it from the App Store. This is a graph of some example of code graph. And searching for a vulnerability is like panning for gold. Okay? How do you do that? What's the process? So first of all, the prerequisites is a lot of knowledge. Okay? You need to be experienced in programming and reverse engineering to be able to say how this code is probably implemented and to be able to understand how it is actually implemented. Knowing how to recognize patterns. For example, if I saw a loop in assembly code 100 times, then it would be very easy for me to identify a loop in assembly again. And if I know what the loop looks like, I can start making some sense of the code that I'm looking at. Same for more broad topics like network communication. As I said, there's lots of patterns to coding, so these things often they look similar. And the most important part is knowing what a programming mistake looks like. Okay? If I am quick to identify these programming mistakes because I've seen them 100 times, then I will be a better researcher. I'm going to skip this to lack of time, but all right. So what tools does What tools does a researcher have under his belt? So first of all, the disassembler, as we said, a program that can take a compiled code and show me the assembly code that it contains. Scripting could be very useful to speed up repetitive tasks. Debugging, anybody who knows what debugging is? Okay, great. So debugging is when you execute the program and you watch how it behaves in runtime. You can see what the memory looks like. You can set a breakpoint, meaning stop the program in this code location, and then see what's happening. It gives a really good insight into how the program actually works. Because remember, we're doing reverse engineering, trying to understand how the program works in order to understand where it makes mistakes. So there is a very popular technique called fuzzing. Fuzzing is when you have some code that repeatedly executes the victim target, the program, for example, and every time giving it a different input. The idea is that some input, if you do it repeatedly many, many times with random or semi-random generated input, then you might strike gold and find the actual input that causes the program to crash. Your job as a researcher is, when it does crash, to look at the exact input that made it crash and investigate what happened. So this is very good in focusing into problematic areas that have bugs, because a program should not crash. It doesn't matter the input you give it, it shouldn't crash. If it crashes, then that's a red flag. Okay, there might be some mistake, some bug, and possibly some security vulnerability. So some challenges in the vulnerability research process. So first of all, not all vulnerabilities are exploitable. We spoke about exploit mitigations. So even if there is a buffer overflow that lets me overwrite the code, perhaps there is a mitigation on the system running this code that makes it impossible to overwrite code segments. So even though the vulnerability exists and on a different system it would be exploitable, if this code only runs on a system with the protection, then it would not be exploitable. So things like buffer overflows, they don't really exist in higher level languages because they have automatic memory management, and as programmers move to higher level languages, these kind of memory corruption vulnerabilities occur less and less. There's more features that are designed to protect code against vulnerabilities, and for example, static analyzers become smarter and smarter and can warn about unsafe code. So the programmer would never even write the vulnerability in the first place. So people could be writing less and less vulnerabilities, and it makes the process of searching for a vulnerability more difficult. Obfuscation. So remember, when reverse engineering, usually you work on the compiled version of the code. Obfuscation makes the compiled version very hard to understand, even though the source code might be simple to understand. Very simple code, it generates very complex assembly. So we're halfway into 2023. I can't not talk even a little bit about AI. So since vulnerability research is about finding mistakes in patterns, what would be better than AI that is very good at studying patterns to do this task? Okay, so that's a really long answer. I asked it to summarize that to one sentence. So the task could be so complex that, yes, AI would become better and better at it, but for complex vulnerabilities, many times the vulnerabilities don't really repeat themselves. So the common problems would be easier to catch by AI, but the more niche vulnerabilities or design flaws could still be out of reach. So yes, AI is becoming better and better at catching vulnerabilities. Like this person found 213 vulnerabilities using GPT-3, while old school classic static analyzer only found 99. So yes, it's getting better, and like everything, all fields that use AI, it's a tool. All right. Yeah. So user interaction is a very important thing. As I said earlier, if I send, okay, so in this example, if I send an SMS message to a phone, it should not compromise the device. It should maybe compromise a minute of the user's time reading it, but that would be a really strong vulnerability if the user opens the SMS message and it hijacks the device. Even stronger vulnerability would be if the user doesn't even have to click it. So just when the SMS arrives into the device, it immediately exploits a vulnerability and executes code. That would be a really strong vulnerability, and that is considered zero click, or in other words, no user interaction. There is a structured process of disclosing vulnerabilities. Why would anybody want to do that? So to receive a bounty or to fix the vulnerability, making the world safer. And disclosed vulnerabilities that become public knowledge, they are they are documented in this database called CVE by Mitre. And over there you can find all vulnerabilities. Each one gets a nice number. Shameless plug, this was mine. And remediation is super important, because once a vulnerability is found, it needs to be fixed. But what if it is already, the code already is installed in somewhere? For example, Fiat Chrysler, there was a research that found many vulnerabilities there, but the code was already in the cars, okay, the entire fleet. They had no method of distributing the patches, the updates, to fix the vulnerability in the field. So the remediation is something that has to be thought of when you create a product. And yeah, so 0 day is the term for a vulnerability that is unknown, undisclosed. 1 day is a vulnerability that is disclosed. So without proper remediation, even a 1 day vulnerability is useful for attackers. So in May 2017, the WannaCry campaign used a vulnerability called Eternal Blue 2 months after it was fixed, right? It still worked on hundreds of thousands of computers. So the propagation of fixes, of updates, is super important. Okay. So to summarize, to do vulnerability research properly, you need a lot of experience. It's getting harder because it's getting more and more automated and well thought the language features and compiler features and exploit mitigations. It's at the core of trusting software. Okay, so not all cybersecurity relies on unvulnerable software. You also need to use it correctly. For example, changing the password of your router. But if you cannot trust the software, then you have a big problem. And keep your software up to date. So even disclosed vulnerabilities cannot be used against you or your organization. Is there any questions? We have